In this example, example 2, the question is find the shortest distance from origin to the curve. So I'm given here the curve and I want to find the distance between the point on the curve and we want to find the point distance from the origin to the point of the curve. So distance will be equal to root of x square minus 0 plus y square minus 0 is equal to x square y square. And we can say if this is maximum, then this is also maximum, x square plus y square. So I say if this x square y square is maximum, I can replace it by the function fxy. My fxy is equal to x square plus y square, and my condition for this one to be maximum, shortest, smallest, minimum, is that this must be on the curve y square over y square y is equal to 16. That gives me gxy. So my gxy is equal to x square y minus 16 is equal to 0. So I have the function and I have the condition. I have the function here. Now I am having here fxy is equal to x square plus y square, and I have the condition gxy is equal to x square y square minus 16 equal to 0. So here I was given here the condition, but the function was not given. I have to generate the function by using the concept given in the problem. So this is the first stage, we have to do it, and then we having the function and the condition, and we proceed by using a Lagrange multiplier. To use a Lagrange multiplier, we are going to have here, so I can take the gradient of this one, gradient of f is equal to f of x is 2x, then derivative to y is 2y, and I find gradient of g is equal to g of x is equal to 2xy, and g of y is x square. So I use the Lagrange multiplier equation that's here is my gradient of f is equal to lambda time gradient of f is equal to lambda time gradient of g, and that give me here the function here. This is equal to 2x, 2y is equal to lambda times I have 2xy x square. So the equation I got from here is 2x is equal to 2 lambda xy, the equation 1, and this 2y is equal to lambda x square. And third equation I get gxy equal to 0 is x square y equal to 16. This set of three equations from here, I need to find the value of x and y from these equations. So this is my equation 1, this is my equation 1, this is my equation 2, and this is my equation 3. From equation 1, we can rewrite it. We can write here this 2x minus 2 lambda xy equal to 0. So we can write here this is, I take 2x common, and we get here 1 minus lambda y equal to 0. So here we can say x is not equal to 0 because we want to find the shortest distance. When x equal to 0, then condition this x square y is not equal to 16, that's not satisfied. It means x is not equal to 0. If x is not equal to 0, then it means 1 minus lambda y is equal to 0, and that gives me lambda y is equal to 1, and my y is equal to, I can get here the value of y is equal to 1 over lambda. So here I get the value of y. So this one equation I get. So we are having here using this equation, we go further, and we can use our second equation, equation 2, in which I have here 2y is equal to lambda x square. We have equation 2, in which we have 2x plus lambda x square, and we have found the value of y is equal to 1 upon lambda. So put the value of y here, we get here 2y is equal to 1 upon y x square, and here we get here multiply by y, we get 2y square equal to x square. So I have here now equation 3, I put the value of x square in equation 3, I get 2y square into y equal to 16, and that gives me 2y cube minus 16 equal to 1. And then we just factorize this one, I get here 2y minus 2y square plus 2y plus 4 equals 0. You know when it is cubic equation, we have only one real root, and the one real root is y equal to 2. The other roots are imaginary, we don't consider it. Now I substitute this y equal to 2 in my equation 3, I get the value of x. We get here 2x square equal to 16, and x square is equal to 8, and we take root of both the sides, we get x equal to plus minus 2, 2. So here we get here 2 points, 2 root of 2, 2, and minus 2 root of 2, 2. Now we get the value of the function at these 2 points. The largest value will be maximum, and the least value will be minimum. So I find here the value of the function fxy. This is 2 root of 2 and 2. 2 root of x square is 2 root of 2 whole square plus 2 square. So that gives me 8 plus 4, and that's equal to 12. We find the second value of the function at the point minus 2 root of 2 and 2. That's also, I get here minus 2 root of 2 whole square plus 2 whole square. Again, I get here 8 plus 4 is equal to 12. So we say this function will get the least value at 2 points. The function, this least distance or smallest distance, as we having in the question, we use that on the language same. The question of the language was that we are having here the shortest distance. We are having here shortest distance from origin to the curve x square y equal to 16 is on point. The points are here 2 root of 2, 2 and minus 2 root of 2, 2, and distance is equal to 12 units. So that's this answer of the problem. We go further and we use the Lagrange multiplier to find the maximum minima for the function of 3 variables with subject to condition. We have the function of x, y, z, and the condition is g, x, y, z. So if we write the Lagrange multiplier for this one, we have the gradient of f is equal to lambda time gradient of g, as we did for the 2 variables. Now here if I find the gradient, this is my function, this gradient is derivative respect to x, derivative respect to y, and derivative respect to z, and here it's lambda time the derivative of g with respect to x, g with respect to y, and g with respect to z. This is another application of our gradient. Now when these two vectors are equal, we can write here 3 equations. Number 1, f of x is equal to lambda time g of x, we having f of y is equal to lambda times g of y, and we having f of z is equal to lambda time g of z. And then we have the constraint, because we having the unknowns are x, y, z, and lambda, the Lagrange multiplier. So we take here with separate condition. Our condition is g, x, y, and z equal to 0. So we solve these 4 conditions for 4 unknowns. So we drop the value of x and we get different values. For example, we get x1, y1, z1. We get the point x2, y2, z2, and so on. And then we calculate the values of the function at this point. The maximum value will be the extreme value, the largest value will be the maximum value, and the smallest value, the least value will be the smallest value, minimum values. So that's the same idea as we discussed in the discussion for 2 variables, we will discuss for 3 variables. So I explained you with the help of example.